right, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. This is number 32 on a series on series. For each of the following sequences, kind of the precursor to series, whose nth terms are indicated, state whether the sequence is bounded and whether it is eventually monotone, increasing, or decreasing. So if you were here for 31, kind of talked about what all that means. You can go check that out. I'll kind of go a little bit more into detail in that video, but bounded basically just means that it's going to be approaching something as it goes to infinity, positive infinity, and monotone would mean that it's always doing something. It could be increasing, decreasing, and then it could also be like just a flat line. Like if you have a constant would be monotone constant. Monotone increasing and decreasing are far more likely, but it could be any of those three technically. So let's look at what this one might be doing. And the best way, I think, to do these is just to kind of whip out a table. So we're going to call this whole thing A. And we're going to look at values of n as they go to infinity and what's happening to our function. And I might need to break out a calculator for this one, because we're going to start at, I think, 1. It didn't leave me any instructions on what we start with here. So I think yeah, I think we're starting with 1. So if they don't say, typically sequences start at 1. A series will start either at 0 or 1. I think 0 might be a little more more likely, but if they don't say what the sequence starts at, it starts at 1. So this would be the ln of 1 plus 1 over 1. 1 over 1, of course, is 1, and then 1 plus 1 is 2, so this is the ln of 2, and that is an irrational number. And actually, all of these are going to be irrational because we're going to be going by rational numbers here. And ln is a log with a base of e, so it's e to what power equals a rational number? Well, e to any normal power would be an irrational number. You'd have to have like a really, really crazy power to make it so that it's not irrational. So we're going to end up with irrational values for all of these, but we can still figure out what it would be. For 2, that would be 1 plus 1/2 is 1.5, or 3/2, the ln of 3/2. All right. Then we'd have the ln of 1 plus 1 over 3, which is 1 1/3, which is 4/3. And another way to write this one, actually, I'm thinking about, I want to write these so that it's easy to see what the pattern is. 2 can be written as 2 over 1. So if you look at the pattern, it's 2, 3, 4, 1, 2, 3. So if we go to some sort of arbitrary n value, another way to write this would be, it would be the ln of n plus 1 over n, which is exactly what we would get if we were going to add these, right? Because that would be 1 over 1, and then times up by n, and then that's n plus 1 over n. So that's just another way to write the same thing. And if we're going to go to infinity, then it would essentially just be the ln of 1, because as you're going to infinity, the percent difference in the numerator and denominator decreases, right? So 2 is twice as much as 1, 2 over 1, but 3 is only 50% more than 2. And then the percent difference decreases down to basically 0, and as you're going to infinity, you could say that the percent difference basically becomes nothing, meaning that the difference between the numerator and the denominator is so insignificant that they might as well be the same number, which means it would be the ln of 1. And the ln of 1 is 0. Okay, So now we just need to estimate some of these values. So I'm going to whip out my calculator here because I don't know these values by heart. And we want to find out what the ln of 2 is first. So that is 0.69. I'm going to write these estimates down below here. 0.69. All right, what about the ln of 1.5, or 3 halves? 0.41. I'm rounding to 2 decimal places here. So we can see it's going down, and my guess is that it would be going down to 0. Let's do the other one, 4/3. ln of 4/3 is 0.29. Yeah, pretty small. And just to check, what you can also do is if you're not really sure, if it doesn't seem like it's super obvious, you can always try a really, really large value, right? Because we know the formula is n plus 1 over n. So let's say ln of, and let's say the n value of 1,000. 1, 0, 0, 1, right? N plus 1, 1001, over 1, 0, 0, 0. And that is 0.0009995. So basically 0.001. And I'll go ahead and write that down as well over here. So the ln of 1001 over 1,000. Yeah. And that is, I mean, if you're rounding to 2 decimal places, that would round to 0, right? But if I round just so that I have something other than 0, then I would round and I would get that, 0.001. But again, to 2 decimal places, that would be 0 at that point. So if we're only considering 2 decimal places, we've gotten to basically 0 by the time we get to 1,000. So it's kind of going a little slow compared to some series that you'll run into later. But that's what's going on here. So, okay, so now what do we do with all this information? Well, remember, the question is it bounded? AKA, more or less, does it have an infinite limit? And it does. The limit as it goes to infinity is 0. So it's bounded. We could say it's bounded. So a sub n is bounded. Bounded. I can spell. Bounded. Speaking of forgetting to things and stuff, I forgot to write series. So I'm going to write the first series in that color because that represents that we've already done the first 30. And then this is the number 32. So 1, 2. This is the second video in this particular set of 30. And I'm also doing them in months that have 30 days. So we didn't do any last month in May. This is June. So we're picking it back up. That's the plan anyways. So anyways, a sub n is bounded. Bounded by what? I don't know. You could say it's bounded by the line y equals 0 or by the x-axis. You could say something like that if you wanted to. It just depends on how your professor wants to answer. At this point, it's like, okay, it is bounded, and then the nitty-gritty is kind of up to how your class needs to do it. So I'm not going to get too much into all the different ways you can answer this. I'm just going to answer it kind of as directly as I can. And then the rest of it's kind of up to you, because there's so many different ways that a teacher might want you to word things, and they could be really strict with that. So I want to try to make sure I'm not giving you false information for your class specifically, if that makes sense. So anyways, so it is bounded, and is it monotone? If it is monotone, is it increasing or decreasing? Because by and large, increasing and decreasing are really the only two options. It's bounded, and is it only decreasing? I think it is. I think it is only decreasing. Now, if you wanted to make sure that it is only decreasing, then you would say something like a sub n plus 1 is less than a sub n. Right? The next term in the sequence will always be less than the previous. And in order to prove something like that, you would say the ln of and it's n plus 1 over n, right? So n plus 1, it would be n plus 1 plus 1, right? N plus 1 plus 1 over n, which is now an n plus 1. So I'm plugging in n plus 1 in the place of n. Less than ln of n plus 1 over n. Okay, and then we say, okay, well, can we say that that's more? Well, that would be n plus 2 over n plus 1 ln of n plus 1 over n. Both of them are ln's, so we can actually kind of just cancel them out. E to the power of ln of something just cancels. So then this is n plus 2 over n plus 1 less than n plus 1 over n. And yeah, so that would end up, if you cross multiplied, which I'm not sure if you like should technically do it that way, but if you cross multiplied, then it might look something like n squared plus 2n. Yeah, n squared plus 2n, and then the other one would be n squared plus 2n plus 1. And actually, that might be fine. Some teachers don't like it when you're timesing both sides, but there's not going to be a 0 n value because your n's are starting at 1. So there's not a potential for like timesing both sides by a number that could potentially be 0 or -1 and cause a problem because you can't divide by 0. So I don't think that should be an issue. You should just be able to times both sides by it, and then you would say n times n plus 2. It's been a little laggy. Hold on. There we go. N plus 2. Come on. I think I have too many tabs open. I need to go close my tabs. And then we have n plus 1 times n plus 1, or n plus 1 squared. I'm just going to write n plus 1 n plus 1. Because I'm going to FOIL these out. I'm going to distribute and FOIL n squared plus 2n less than n squared, and then plus n, so plus 2n plus 1. So look at that. We end up with 0 is less than 1, which is true for all n values. So there we go. So something like that would probably be more than enough for most professors. A sub n is bounded, and it is always decreasing. It's monotone decreasing. Bounded, I'm just going to put and. Bounded and monotone. Monotone. I cannot spell today. Monotone decreasing. And you might be thinking like, oh, that's such a weird way to say it. We don't say it like that. What are you doing? There's so many different ways to say it that are acceptable way. You could say monotonic. That's another way I've seen people say it. It's decreasing and it's monotone and decreasing. Monotonic decreasing. There's so many different ways. So don't judge me too hard. If you guys say it a certain way, then say it that way, because that's your professor's giving you the grade. So anyways, that's sufficient for an answer, and that'll wrap up this question. Hope that's been helpful. If you want to check out other stuff, I've got the 5 math mistakes everyone makes and how to avoid them. That is a free PDF guide on my website, Myers Mathematics, which is in the description down below. And I'll catch you guys in the next video. Blessings, y'all.